One of the ways that we look at the heart's health and its relationship to homeostasis is with these graphs called pressure volume loops. In clinical medicine, you are not going to see very much of this kind of a representation of what the heart is doing. Okay, this is more for physiology, like looking at how it works. Instead, what you're going to see is these pressure volume loops. All right, it's actually showing you the same thing. The graph we've spent so much time talking about today is you've got time on the x-axis and then what's changing on the y-axis. Here, what you have is you're looking at volume of the ventricle versus pressure of the ventricle. This works well for the heart because it's cyclic, right? It keeps doing the same thing over and over and over again. So we can take our first graph and kind of wrap it in time and look at it this way instead. Okay, so let's start at point number A, or point letter A. So this is end systolic volume. The heart has contracted as much as it's going to contract. It is as small as it's going to be, right? So at the end of systole, the heart has started to relax, right? Because diastole is about to begin. So we have very low pressure in the ventricle, and we have very low volume in the ventricle. All right, so that's our starting point. Low and low. Now, AV valves open, right? So the left AV valve and right AV valve open at this point. Now blood can fill the ventricle. Okay, so what we see here, this is our filling time, right? This is our period of filling or ventricular filling. We can see that the pressure is low, but the volume, the x-axis, is increasing dramatically. The heart is filling up. Now, when we get to B, we have end diastolic volume, because now the heart's done relaxing, it's about to contract. At B, contraction, here's atrial contraction, right? We get our little bump in pressure. We still get an increase in volume. Here is where ventricular systole starts, because the mitral valve closes very quickly. Now we see pressure is increasing. That's the y-axis. Pressure is increasing, but volume is not increasing. This is isovolumetric contraction. Its name literally describes this relationship. The volume is not changing, but the contraction strength is, right? The pressure is increasing. Now, when the ventricular pressure gets greater than the aortic pressure, the aortic valve opens. Now we get two factors are changing. Our pressure is still increasing, y-axis, right? But our volume is decreasing. Why? Because we're ejecting, right? We're actually pushing blood into the circulation. So that continues until pressure in the ventricle falls below the pressure in the aorta. Then the aortic valve closes. We get the heart decompresses. So the heart, the contraction, the pressure drops, but the volume doesn't change. And then we're down here to end systolic volume, and we can go around again, right? So it's the same information we've been talking about. It's just instead of putting it in time, we're putting the volume cross with the pressure, okay? We still have a good stroke volume. The difference between ventricular volume empty and ventricular volume full is the stroke volume, right? So same idea. Now, what the heck is this? Well, the heart can change what it does. Not infinitely, but it can in fact change what it does. But there are limits, like we can't just keep adding more blood to the ventricle. At some point it's so stretched out that adding more blood literally adds pressure. That's what we're seeing at the end here, right? So this is the physiologic range. This is, if you studied it, this would be the pattern. But what we see in life is this middle part. Okay, so pressure volume loops and how they're important. This is the one you should put a little asterisk by. This is the important one on this slide, okay, even though it's not the bigger one.